Rudolf Clausius was 43 years old in 1865 when he stood before the Zurich Natural History Society and wrote two sentences on a chalkboard that between them constitute the most complete summary of physical reality anyone has ever managed. The first sentence said, "The energy of the universe is constant." The second sentence said, "The entropy of the universe tends toward a maximum." He was not dramatizing. He was not trying to be poetic. He was summarizing 30 years of laboratory physics in the most compressed form the mathematics permitted. And what those two sentences say together, if you follow them to their logical end without flinching, is this: everything that exists is running down. All the useful structure in the universe, the temperature gradients, the pressure differences, the concentration of energy in stars, the chemical complexity of living organisms, the electrical signals moving through your brain right now as you listen to this, all of it is borrowed. All of it is a temporary deviation from the final state, which is uniform, featureless, and dead. You are not being kept alive by some upward force. You are being kept alive by the slow release of order that was installed in the universe at the Big Bang and which has been draining away irreversibly ever since. Arthur Schopenhauer wrote that down in 1819, without the equations, without the laboratory, working entirely from philosophy, from introspection, and from what I can only describe as an almost pathological willingness to follow an argument wherever it went, regardless of how much he personally hated the destination. He was 28 years old. He called the thing that drives existence the will, a blind, purposeless, insatiable striving that underlies all matter, all life, all desire, and all suffering. And his conclusion about the will was the same conclusion Clausius reached about entropy 46 years later by a completely different method. It cannot be satisfied. It does not tend toward order, toward meaning, toward happiness, or toward rest. It tends toward dissipation. It tends toward the state where nothing further can happen. I want to be careful here because I am a physicist and I have spent my career being careful about what I am actually claiming versus what I am merely suggesting. I am not claiming that Schopenhauer discovered the second law of thermodynamics. He did not. He had no mechanism. He had no mathematics. He had no experimental program. What I am claiming is something more interesting and I think more unsettling, that a philosopher working from pure observation of human experience converged on the same structural conclusion as the physicists, that the deep tendency of all things is toward disorder, dissipation, and the exhaustion of available energy, and that the reason he got there is that the second law is not merely a law of physics, it is the operating system of reality. And if you look honestly at what reality does to conscious beings who live inside it, you cannot miss it. Let me give you the physics first, because the physics is both simpler and stranger than most people know. When Clausius coined the word entropy, he was trying to measure something specific. How much of the energy in a system is unavailable to do work? A hot object and a cold object placed next to each other will exchange heat until they reach the same temperature. Everyone knows this. What is less obvious is why it always goes in one direction. Why does the hot object cool down and the cold object warm up? Why not the reverse? The fundamental laws of mechanics, Newton's laws, the equations of motion, are time symmetric. They work exactly the same going forward as going backward. There is nothing in the basic equations of physics that distinguishes the future from the past. And yet we never see heat flow from cold to hot spontaneously. We never see a broken egg reassemble itself. We never see smoke curl back into a cigarette. The universe has a direction. It moves from the past toward the future and not the other way around. And the second law is what defines that direction. The reason was worked out by Ludwig Boltzmann in the 1870s, and it is one of the most important insights in the history of science. The reason heat flows from hot to cold is not because there is a law forbidding the reverse. It is because the reverse is so improbable as to be for any macroscopic system effectively impossible. A hot object contains energy concentrated in a small number of particles. A cold object has the same energy distributed more evenly. There are vastly more microscopic arrangements of particles corresponding to the mixed state than to the concentrated state. So when the particles interact randomly, they almost inevitably move toward the more probable, more mixed configuration. The probability of them spontaneously organizing themselves back into the concentrated state is not zero. It is just a number so small that the universe does not contain enough time for it to happen once, even if you waited for longer than the current age of the universe multiplied by itself 1,000,000,000,000 times. For practical purposes, it never happens. The direction of time is not written into the fundamental laws. It is written into the statistics. The universe moves from order to disorder, not because it has to, but because disorder is overwhelmingly more likely, and random processes, given time, find likely states. This is the second law stripped to its bones. And now let me tell you what it implies about the universe as a whole, because this is where it gets dark. The universe started, as far as we can tell from the physics, in an extraordinarily low entropy state. The Big Bang produced a universe that was hot and dense, but surprisingly uniform. And when you account for gravity, uniformity at the beginning of the universe represents an almost incomprehensibly improbable configuration. The entropy of the early universe was perhaps 10 to the 88 Boltzmann units. The entropy of the observable universe today, dominated by the supermassive black holes that have been growing for 14 billion years, is something like 10 to the 104. We are sitting somewhere in the middle of an irreversible process, a long, slow cascade from a specific, ordered, low probability initial state toward a final state that physicists call the heat death of the universe, a state of maximum entropy where no further useful processes are possible, where temperature has equalized everywhere, where no concentration of energy remains to power chemistry or biology or anything else. Every star will burn out. Every black hole will eventually evaporate via Hawking radiation. The last black hole will take something like 10 to the 100 years to evaporate. After that, the universe will be a thin, cold soup of photons and leptons, expanding forever, growing more dilute, moving further and further from any state in which anything interesting can happen. That is where this is going. That is what the second law says is the endpoint of all physical processes. Clausius knew this. He said it plainly in those two sentences. The energy is constant, meaning nothing is being created or destroyed. And the entropy is increasing, meaning the fraction of that energy that is available to do anything useful is monotonically, irreversibly decreasing. Not probably decreasing, not decreasing on average. Always, everywhere, without exception, decreasing. The universe is not in a steady state. It is in a drawn-out process of becoming unavailable to itself. Now, Arthur Schopenhauer, I want to read you something he wrote in 1818 in The World as Will and Representation. He wrote, "All striving comes from want or deficiency, from dissatisfaction with one's own state or condition, and is therefore suffering so long as it is not satisfied. No satisfaction, however, is lasting. It is always merely the starting point of a new striving. The striving we see everywhere met with no final goal. There is no measure or end to suffering." When I first encountered this passage, I was a graduate student, and my reaction was what most scientists' reaction would be. Interesting psychological observation, probably overstated, does not constitute an argument. That was wrong. I was too quick. Schopenhauer was not making a psychological observation. He was making a metaphysical claim, and the structure of the claim is identical to the structure of the second law. Let me show you why. Schopenhauer's fundamental insight, the thing his entire philosophical system is built on, is that all desire is a manifestation of the will, which is not a conscious intention but a blind striving that underlies all matter and all life. The will has no purpose and no goal. It strives because that is what it does. The way mass falls, because that is what mass does. And the crucial observation is this: the will can never be satisfied. When desire achieves its object, the satisfaction is temporary and immediately replaced by a new desire. This is not a psychological pathology. This is not a character flaw. This is the structure of the system. The will, like entropy, is not looking for an equilibrium state in which it can finally rest. It is looking for the next gradient to run down. And there is always a next gradient until there isn't. This is precisely the thermodynamic picture. In the thermodynamic picture, every physical process is a gradient running down. A concentration of heat disperses until it equilibrates with its surroundings. A battery discharges until the electrochemical potential equalizes. A star burns through its nuclear fuel, converting gravitational potential energy into radiation until it runs out of fuel and collapses. Life exists because it is extraordinarily efficient at running down gradients, at converting low entropy solar energy into high entropy heat while doing useful work in between. But every act of living, every act of desire and its satisfaction is thermodynamically a gradient being destroyed. You eat because you are hungry. You generate heat. The low entropy chemical energy in the food becomes high entropy thermal energy in your environment. The hunger returns. You eat again until you don't. The second law makes no exception for beings that are conscious of what is happening to them. Life is not a refutation of the second law. Life is, as some physicists have argued, an acceleration of the second law. We are not swimming against the current of entropy. We are the current. Schopenhauer arrived at this from the direction of consciousness, from the phenomenology of what it is like to be a desiring being trapped inside a body that the will is using as an instrument. I arrived at the same picture from the direction of statistical mechanics and the behavior of large ensembles of particles. The convergence is not a coincidence. It is, I think, a consequence of the fact that both investigations were aimed at the same target. What does reality actually do, stripped of wishful thinking? And here is where I need to be precise about something, because there is a version of this argument that is sloppy and I do not want to make it. The sloppy version says the second law proves pessimism. The universe is running down, therefore life is meaningless, therefore suffering is the fundamental fact of existence, therefore nothing matters. That is not what the physics says, and it is not what the best version of Schopenhauer says either. What the physics says is that useful structure is impermanent. It does not say useful structure is negligible. The fact that the sun will burn out in 5 billion years does not subtract anything from the fact that it is right now maintaining the biosphere that produced Bach and the theory of general relativity and Schopenhauer's own grim masterpiece. The fact that every desire is succeeded by a new desire does not mean that no desire is ever satisfied. Schopenhauer knew this. His pessimism was not a claim that nothing good exists. It was a structural claim about the ratio of satisfaction to striving over any sufficiently long time period. And on that point, the physics and the philosophy agree. Averaged over cosmic time, the fraction of time any part of the universe spends in a low entropy, high structure, desire-capable state is vanishingly small. The default state of matter is not life. It is not consciousness. It is not the capacity for suffering or joy. It is the heat, death. Everything else is a fluctuation. There is something else Schopenhauer saw that the physics confirms, and this one I find genuinely difficult to sit with. He observed that the will is expressed through individuals, but it does not care about individuals. It uses individual organisms as temporary vehicles for its own perpetuation, discards them when they are no longer useful, and replaces them with new ones. This is, word for word, the Darwinian picture of natural selection, which Schopenhauer predated by 40 years. It is also, more abstractly, the thermodynamic picture of dissipative structures. Ilya Prigogine won the Nobel Prize in Chemistry in 1977 for showing that under certain conditions, far from thermodynamic equilibrium, organized structures can spontaneously appear and persist hurricanes, convection cells, and at the relevant scale of complexity. Living organisms, these structures are not exceptions to the second law. They are expressions of it. They exist because they accelerate the production of entropy in their local environment. They are sustained as long as they are doing that job effectively and destroyed when they are not. The universe maintains them not because they are valuable in themselves, but because they are useful instruments of dissipation. And when a better dissipator is available, the old one is replaced. If you are a human being reading this, I want you to sit with that for a moment, because what it says is that the consciousness you are using right now to understand this argument, the sense of being a particular person with a continuous history and a stake in your own future, is physically a temporary, low-entropy structure maintained by the second law for as long as it serves the second law's purposes, and that will be dissolved by the second law when it no longer does. This is not poetry. This is what the Boltzmann entropy formula actually implies when applied consistently to biological systems. Schopenhauer was not being melodramatic when he said the world is driven by a blind force that uses conscious beings without caring about them. He was being accurate. And yet, and this is where Schopenhauer and I part company, at least somewhat, I do not think the correct response to this is the resignation he ultimately recommended. I understand why he recommended it. He was a very precise thinker and a very honest one, and what he saw clearly was that the alternative, the pursuit of permanent satisfaction through the accumulation of things, relationships, achievements, pleasures, is guaranteed to fail on its own terms. The hedonic treadmill, as psychologists now call it, is not a quirk of human psychology. It is built into the structure of desire, which is built into the structure of the will, which is built into the structure of a universe governed by the second law. Satisfaction is always temporary. Striving is always renewed. That is not going to change. But what Schopenhauer perhaps underweighted, and what I think the physics actually suggests, is that the intermediate state is real. The gradient between low entropy and high entropy is real. The energy that flows through that gradient and does work along the way is real. The music that happens between the plucking of the string and the silence that follows is not less real for eventually falling silent. There is a version of this that is comforting, and I distrust comfortable versions of hard arguments. But there is a version that is simply accurate. The second law does not say that nothing good exists. It says that nothing good persists. And the question of whether transient good is sufficient good, whether a universe that produces temporary consciousness capable of understanding its own thermodynamics is better than a universe that reaches the heat death without ever having produced anything that could contemplate the heat death, is a question the physics cannot answer. It is a question Schopenhauer asked and answered too quickly in the direction of resignation. I am not going to tell you the answer. I have spent 50 years thinking about what the universe is made of and how it works, and I have become progressively more reluctant to make confident pronouncements about questions I cannot formulate as equations. What I will tell you is that the second law is real, Schopenhauer's diagnosis is structurally correct, the heat death is coming, and in the meantime, the universe produced, for reasons that are entirely explicable by physics, and entirely astonishing nonetheless, a temporary low-entropy configuration of matter that can write string theory and Beethoven's late quartets and pessimistic philosophical masterworks from the early 19th century. That seems worth noting. Whether it is worth anything more than noting is a question you will have to answer for yourself. I have not managed to answer it, and I no longer pretend otherwise.